Now we're going to talk about adding and subtracting rational expressions. Do you remember when we're talking about adding or subtracting fractions? 2/15 plus 4/15, we add them up, we would get 6/15, right? Get a common denominator. Add the tops, keep the denominator the same. Simplify the fractions, so it will be 2/5. So now, let's do the same thing with rational expressions. Well, this one's beautiful because we have a common denominator. We keep the denominator the same, and then we're going to add or subtract the numerators. In this case, we're adding, so it's x take away 2 plus 4x. Now, we never want to leave it like that because we can combine like terms, so we get 5x minus 2/3y. And I'm actually done with that because I can't factor or simplify or get anything done more. So we're done. Now let's do the next one. So we're going to add the numerators, keep the denominator the same. So it's y squared plus 2y plus 3y minus 14. Combine like terms. Y squared plus 5y minus 14. Now, again, I am going to tell you that these problems are probably rigged. And this one is, I can factor my numerator, y plus 7 over y minus 2. Check your cradles. Y plus 7, we divide out, we get a 1. We're left with y minus 2, and we're done. Next, let's look at this one. Well, thank goodness for common denominators. And I'll get 2x minus 4. Now we're going to see if we can simplify. And worst comes to worst, you factor and nothing cancels, who cares? You know what I'm saying? In the numerator, you can factor out a 2. Denominator, we're going to write it as x, opposite signs. The beauty of it is the leading coefficient is 1, so you need a plus 5 and a minus 2. Oh, shocking. It's rigged. Again, we get 1s here. 2 over x plus 5. It's simplified. Perfect. Now let's do another one. Now these can be a little bit tricky, you guys, so I'm going to show you. So 6x minus 4, we're taking away this entire binomial. So we have to be sure to subtract everything. So change the sign through that whole second polynomial there. So here we go, 6x minus 4 minus 5x minus 3, because I'm changing my signs. So we're going to combine like terms, so we get x minus 7 on the top. And in the denominator, we're going to factor, we get x minus 7 plus 5. Look at that. We can divide out. We have a 1 left on top, you guys. Keep it straight where everything is located. If you have it seems to have everything is canceled or divided out in the numerator, stick a 1 there. And you need to leave it in, all right? Next. All right, now what about unlike denominators? So let's take it easy on this. So the first thing we're going to do is get the least common denominator. Remember this? Just coming back to fractions, 1/2 plus 1/12. I need a common denominator, a number that both 2 divides into and 12 divides into. So that number would be 12 because 2 divides into 12 6 times and 12 divides into 12 once. But now what to do with polynomials in the denominator? Well, first, just like anything that we've been doing so far, we're going to factor those denominators. Good? And to get a least common denominator, this is how you do it. Anything in common, you write it down once. And so this is my denominator category. I'm not done yet. Okay. And then anything else that's left over, you just write it down in front. So my least common denominator is 7a times the quantity a minus 3. And you never multiply anything out again. Next. So now all we're doing, you guys, is getting the least common denominator. We're not adding or subtracting or anything. So this is what we're going to do for this guy. Well, I'm going to break her down. So 25 and 10. 25 is 5 times 5, and 10 is 5 times 2, and then I have my little x's and my y's, okay? So anything in common, 5 and 5, x and an x, you write down once, 5x. The rest of it, you just write down in front, and I didn't leave enough room in front, so we can write it in back. So we need another 5, a y, a 2, and another x. So the denominator, that is the LCD, we're getting the least common denominator, would be 5 times 5 times 2 is 50, x times x is x squared, and a y. Now suppose you say to yourself, well, I don't want to do it that way. So I'm looking at my denominators again, and between 25 and 10, the least common denominator is 50, right? And then between x and x squared, you're going to pull the greater one, the one that we need the most of. So I need an x squared, and then I just need a y. Good? So you can get it the same way. But this is just broken down a little bit more. Okay, how about the next one? All right, so what we're going to do is we're going to write down our factored denominators. So you circle what's in common, and you write it down once. Good. And then you write down the leftover. Done. All right, moving on. All right, remember when you were a kid, you did this. Blank over 12. 2 times 6 is 12. I have to multiply by 6, and so I get 6/12. You're really multiplying that fraction of 1/2 by what number? Answer? 1, but it's a different form of 1. It's the form of 1 that we like. So let's do that. Same deal with rational expressions. So I'm going to write down my first fraction. And in the second fraction, you guys, I'm going to factor it. Perfect. So then I say to myself, okay, what do I have to multiply x plus 3 by to get 5 times x plus 3? And the answer is 5. But what I do to the bottom, I have to do to the top because I'm really multiplying by 1. So I'm multiplying both of these by 5. I get this guy, leave him as he is. And then I multiply my top guys, it'll be 10x. Perfect. Done. So now I'm getting an equivalent expression. An expression equivalent to this fraction. Okay, here we go. Next. Alrighty, but let's factor where we can here. We get y times y plus 9. And then we factor this sucker, right? Nice. Okay. Then I say to myself, self, how do I get from y times the quantity y plus 9 to this quantity? Well, you got to multiply by y minus 5. So I do that on the bottom, and I do it on the top. and I get 7 times y minus 5. And for this problem, you guys, we're done. For the full-blown adding and the subtracting of these rational expressions, we won't be done. But to get the equivalent expression, we're all set, okay? Now, let's take a look at this sucker. Now, don't start doing all kinds of fancy-dancy things, because what do you notice about these two denominators? They have the same sign and the terms are switched. So what do? You say, oh, I just pull out a -1. Yeah. So to get from the denominator on the left to the denominator on the right, I just have to multiply both the top and the bottom by a -1. So I did that. So the top will become -3x. You good? -3x. Done. Next. All right, now we're to the full-blown problems. Add or subtract using unlike denominators. Let's go for it. So the first step, we have to get an LCD. That's the first step. Second step, equivalent fractions. Good. Third step, add or subtract numerator. And then simplify. So if you keep focused on these steps and don't panic, you're going to be golden. Okay, let's do LCD. So let's get the LCD of these, and I'm going to do it below here. Well, I have y squared, so he's got to go down there, right? And then I have a 2. Good? So again, if you want to do it visually, you get 2y and y squared, which is y times y. You circle what's in common, write it down once. Then write down what's left over, and you'll get 2y squared. Cool? So either way you do it, you guys, it works. So now I say to myself, how do I get from 2y to 2y squared? Well, I need to multiply both the top and the bottom by y. Good? So we'll get y times y plus 2. Perfect. Just relax. Now I need to get from y squared to 2y squared. So I'm going to multiply both the top and the bottom by 2. So I'll get 8. Okay, so we did equivalent fractions. Now we're going to add or subtract the numerators. So here we go. So get y times y plus 2 minus 8. And your denominators stay the same. Now the last piece is to simplify, which takes a little while too. I'm going to distribute this y through. Y squared plus 2y, take away 8 over 2y squared. Now, just for fun, we're going to factor the numerator into y plus 4 and y minus 2. But you guys, there's nothing we can divide out here. So you can type your answer, in your homework assignment either way for these, because the simplification is not there. Good? Perfect. Now let's do the next one. We think about, we're going to write a common denominator, and these are package deals, you guys. Therefore, we have to write them both down. And now what we're going to do is say to myself, oh, I need to get an equivalent fraction. I already have my y plus 4. I need a y minus 1 on the top to make sure I have my 1. See how cute? Well, what do I need for this guy? Well, I already have the y minus 1, so I need the y plus 4. Perfect, you guys. Perfect. And now what do? Well, I keep the denominator the same, and I subtract or add my numerator. So I'm going to just write it down as is, you guys. Perfect? Now I'm nowhere near done. So I have to multiply this guy out, multiply that guy out, and subtract. So here we go. 2y squared minus 2y. And we have to take away y squared. What am I doing? I'm foiling, you guys. All right? Y squared. And after I FOIL and combine like terms, I'll get that. Okay? You can try that. And the denominator, just leave it the same. The beauty of it is once you get a common denominator, just tag it along, and then we'll work on the numerators. Now this one's tough because it's a subtraction, so I have to distribute my negative. So I'm going to get, let's go all the way over here, you guys. 2y squared minus 2y minus y squared minus 5y minus 4. All over y plus 4 times y minus 1. So in the numerator, combine like terms. Here we go. Y squared. Combine these guys. I'll put a box around these. 7y and then minus 4. But guess what, you guys? I'm kind of excited because that numerator is not going to factor. So you just leave it as is and keep the denominator factored. You don't have to multiply it out. Beautiful. Alrighty then. This one is fun because what do I notice about this second fraction compared to the first one? Look at your denominators. They're the same sign, but the terms are just flipped. So I'm going to do a little trick on this one, because if I do a trick, it'll minimize my work. Keep the first guy the same. And from the second guy, I'm going to factor out a -1 in the denominator and da-da, right? So I'll get 3 minus x. And what happens, the cool thing is, I have subtracting a negative, which gives me a positive in between. Awesome. And I can just get rid of that -1. And now we got a common denominator of x minus 5. And now I'm going to add my numerators up. Combine like terms, you guys. So you get x, zoop, zoop, minus 2 over x minus 5. Remember, these are package deals, you guys. You can't cancel anything. When in doubt, what's the motto? Don't cancel out. All right, these are getting intense, so we're going to factor both denominators. Perfect. First step, LCD. Good, sounds like a light bulb. All right, we write down what's in common, x minus 5 for both of them. Just write it down once. And then write down the leftovers. Perfect. Thank God it's an addition problem. So in the numerator on x plus 3, well, I have both of these guys, but I'm missing x minus 1, so I just write it down. Okay? And then in the second fraction, so what am I doing right now? I'm getting equivalent fractions. Okie dokie. And then I have these guys, but I'm missing x minus 2. Beautiful. Now, here we go. I'm going to try to do a couple of things at once here, you guys. Keep the denominators the same. So here we go. I'm going to totally multiply this out, FOIL this one out, and when I do, I will get x squared plus 2x minus 3. Yes, I will. And then, if I multiply this guy out, I'll get 5x squared. And then my outside will be negative 10. My inside will be a positive 1, so negative 9x. And then the last will be negative 2. Cool? All right, now let's combine like terms on the top. And we have x squared, 5x squared is 6x squared. 2x, take away 9x, is minus 7x. Negative 3, take away 2 is a negative 5. And the denominator is x minus 5, x minus 2, and x minus 1. So I added the numerators up. And the numerator will actually factor, you guys. It factors into 2x plus 1 and 3x minus 5. However, it doesn't really help us because nothing will cancel. So you can actually leave it like this or do the factorization to see if it will cancel. But there you have it. So we actually simplified here, finally. Okay? And that is, you know, I have to say these problems are challenging but doable. So go for it. So here's the last example, E. X squared minus 7x all over x minus 2 plus 10. Okay, so we need a common denominator, and the only denominator here of interest is x minus 2. And you're like, well, 10 doesn't have a denominator. We can just put it over 1. So 1 times x minus 2 is x minus 2. That's our common denominator. So x squared minus 7x all over x minus 2 plus 10 times x minus 2 over x minus 2. And you'll notice x minus 2 over x minus 2 is 1, and you could cancel those, but you'd get back to where you started, which you don't want to do. So we're going to distribute this entire thing through. So we will get x squared minus 7x plus 10x minus 20 all over x minus 2. I just distributed and put them all in the numerator because you have a common denominator now. So now we're going to combine like terms on the top. I get x squared plus 3x, take away 20, all over x minus 2. Okay, so x squared plus 3x, take away 20. I look at the factors of 20, 1 and 20, nah. 2 and 10, no. 4 and 5, no. So I'm not even going to bother factoring. I'm just going to leave it like that because it's not factorable anyway. So there you have it. And now you can continue on with this lesson and go into the homework for this module.